taking notes on the math and chemistry stoichiometry unit. Now, there's a few things we need to know before we can get going, and that's some definitions. A chemical equation is a shorthand way of showing what is occurring in a reaction. A shorthand way of showing what occurs in a reaction. And we'll take this example. 2 hydrogens plus 1 oxygen yields 2 waters. That's the formation of water. I'll bring this back into focus for you. Okay, so we've got a couple different parts. A coefficient is the number of molecules needed. We use it in balancing. What you're going to learn is we have a few laws that we need to uphold. Law of conservation of mass, law of conservation of matter, and things like that. The coefficients are the large numbers. So in this case it's 2 and 1 and 2. 2 hydrogens, 1 oxygen, 2 waters. Subscript indicates the number of each individual atom or element. Now we've dealt with subscripts. Our subscripts are those small numbers. It says H2. That means there's 2 hydrogens in that molecule. A reactant is our starting material in the chemical reaction. Now just like before, reaction I will shorten to RXN. Our reactant, I'm going to underline here, is this part of the equation. It's 2H2 plus 1O2. It's everything before the arrow. Our products are the substance or substances resulting from the chemical reaction. Resulting. That means it's what was made. And in this case, I'm going to underline in green. Our products are after the arrow. And in this case, that means it's going to be 2H2O. Now in the middle, between the reactants and the products, we have an arrow. What we say is produces or yields. So how we would read this is 2 hydrogens plus 1 oxygen yields 2 waters. It's just like that. Now one of the things we're going to have to do is balance equations. We need to make sure that all reactions we write are balanced. Why? All reactions must show a conservation of mass. Now this is actually one of our conservation laws. Conservation of mass is a law, scientific law. This means that what we start with, we must also end with. If we start with 2 grams, we end with 2 grams. Now the key, we have keys to balancing chemical reactions, and it's to maintain the same number of each element on both sides of the arrow, both sides of that yield sign. This can be done only by changing the coefficient out in front of the reactants and products. You cannot, stress the not, change the formula, elements, or compounds. No changing subscripts. Now when we do this, we're going to count. I'm going to set it up that we have a zinc, we have a hydrogen, and we have a chlorine to start with. We have a zinc, and I'm going to put them in the same order, a hydrogen and a chlorine to start with. We're going to count. I don't see any subscripts, so that means we've got 1 zinc, we've got 1 hydrogen, we've got 1 chlorine. Over here we've got 1 zinc. Since we have a subscript 2, we've got 2 chlorines and 2 hydrogens. Now to balance, we pick the one that's different. Just pick one. Zinc is the same, hydrogen is different. We have 2 hydrogens as products, 1 hydrogen as reactant, so we can add a coefficient. So if we put a 2 in front of the hydrogen, now we have 2 hydrogens and we have 2 chlorines. So with that said, our equation is balanced because we have 1 zinc and 1 zinc, 2 hydrogen, 2 hydrogen, 2 chlorine, 2 chlorine. If I want to, I can put the number 1s in, but I don't have to. What I want you to do is the next 2.